Thank you very much. My colleagues, Maxim Sakharov, Daniil Zaitsev, and me, Dmitry Revando, were presenting in the paper Endogenous Demand for Money and Default of a Creditor. The problem we study is empirical. Contemporary economics is run by borrowings and debts, by borrowing from consumers and from producers. We're interested in the question, what happens in an economy if some of the debts are not paid back? This results in a state of default for borrowers. The recent news, for example, CNBC, business insolvencies set to rise globally in 2022, or the Evergrande case, defaults exist, and they could be very serious. We're interested in the very specific type of this question. When does default spill over to a creditor, given bank's credit policy? Okay. The problem in studying the issue comes from theory. Economic theory has two types of variables, real and nominal. Real variables disappear after consumption, but nominal variables usually cannot be consumed. This is described by a so-called the Hunt paradox. It uses finite time period economy. If money cannot be consumed, at the very last moment, money has no value. This is why at the last moment of time, there is no demand for money. By backward reasoning, we can infer that at the very first period of time, there will not be demand for money. So this comes the question, how to introduce money into a finite time economy? The question is actually very serious, because behind the question is the question, how does the demand for money differ from demand for consumable goods? This topic is not well covered in existing literature, but possible answers could be found in the papers of Martin Shubik. Results of our paper. We use three basic models to construct the model. The first model is Shubik-Wilson model from 1977, which introduced default as an equilibrium phenomenon. We use Peter Diamond model from 1987, who studied production after a random match between a producer and a consumer, between an entrepreneur and a worker, and also by Beker. The very old paper, Beker introduced demand for labor and leisure, and he describes labor-leisure trade-off. In our model, this operates in the following sense. Entrepreneur produce good, and he enjoys labor time of the worker. This is a so-called managerial approach to production process, but nevertheless, one can observe similar effects in reality. So our model is a general equilibrium model, what means we study interactions of three markets, labor, goods, and credit markets. Equilibrium exists simultaneously at all three markets, and equilibria are described by a wage, a price, an interest rate, and an agent-specific credit default. Our model can be used to study interactions between the markets, and we studied a very special case. When a default of one borrower or from all borrowers is so big that it makes a lender that it results in the default of a lender. Inputs of the model. There are three types of agents. There are many workers. There are many entrepreneurs, continuum of both types, because we studied general competitive, perfectly competitive general equilibrium, and the borrower, and who borrow from a bank. The bank is strategic dummy. It has a fixed sum of money and installs punishment for non-paying debts. Money serves only as a means of exchange because there is no barter in the economy. It has a zero value if left after credit is paid, but if not, then a state of default has impact on utility of a borrower. The logic here is very simple. If a punishment is too low, demand for credit is infinite. If a punishment is too big, there is no demand for credits and all the trade terminates. All the economy stops operating. Production is fixed and production appears after a match between a worker and an entrepreneur. Outputs of the model are described by three markets: the real good market, which is described by equilibrium price, equilibrium demand for good and supply of the good; equilibrium at the labor market, which is described by nominal wage, real wage, and labor supply, or what is equivalent by leisure; and equilibrium at the money market, which is described by equilibrium volumes of credits assigned to borrowers, equilibrium nominal interest rate, and values of default. By state of default, we mean a state when a borrower cannot completely pay out a debt to a creditor. We concentrate only on the last result. We do not study other markets here. Basic relations of the model. Interest rate is constructed following papers of Shubik and his followers. The value of default is defined as how much money is left after a debt is paid. It cannot be positive because money have no value. Money has no value, but if a debt is not paid out, then a borrower has an impact on its utility function. We discriminate in punishments for workers and for entrepreneurs. State of default of a bank appears if total volume of defaults of borrowers is bigger, the defaults are negative, than a sum of money injected into which the bank had before at the very beginning. Results of simulation. There are four basic cases in our model. First of all, there is the classical. We reintroduce the classical monetary theory. When the demand for credits is suppressed by very high punishments, credits are safe for lender. All credits are paid out. This case actually hinders development of trade, production, and consumption in the economy. Interest rates are the lowest. We do not present them here. This case can be found at the left corner at each finger. There are three other cases. The cases 2 and 3 appear when there is default of only one agent. They are approximately the same, but case 4 actually is prisoner's dilemma. Both agents have low punishments for defaults, and they non-coordinatingly demand two big credits, what results in final default. And their cumulative default could be so big that it exceeds the sum of money injected into the economy. And again, the result is a traditional prisoner's dilemma. From non-coordinated demand for high credits without a concern of actions of other agents. Some legends for our graphical simulation. The logic behind the simulation is known for centuries. The smaller the punishment, the bigger demand for credits. The bigger the punishment for default, the smaller demand for credits. Punishments are depicted on at horizontal axis, KW and KE. Vertical axis describe values of default. At each picture, we have a 0 level. This means that below this level, there are defaults. Above this level, there is no default, but money left has no value for a borrower. State of default for workers. We can see that M1 and M5 are values of money. And we can see that here, this is case 1. This is again case 1. This is the classical case. But cases 3 and 4 appear if some of the borrowers has two loose punishments for defaults. But it can also has, for example, here for this case, some money left after the trade. Very similar are constructed states of default for entrepreneurs. And the idea is that these pictures are constructed just in the same order. The most interesting are these slides. It presents cases when the cumulative default of borrowers and lenders is too big and exceeds money injected into the economy. We can see this at the right case, and this is our result. Our model allows to construct these cases. We do not study some regulation measures. We just offer a mechanism, and this model is a setup rich enough to study interactions between nominal and real variables. Nominal meaning demand for credit, interest rates from one side. Real meaning production, labor supply, and real wage, leisure from another side. Thank you very much.